attention to the key network elements which comprise of our GSM and our GPRS network. And in so doing, we're going to look at the mobile phone and the SIM card. We'll then move on to the GERAN, the GSM Edge Radio Access Network, before turning our attention to the core network, be that the circuit switch core, which we use for making and receiving calls, and the packet switch core, which we use for connecting to the internet and downloading web pages and sending emails, etc. So let us begin then with the mobile phone, or more accurately, the mobile station. Now we can see here that the mobile station is actually made up of two key elements. The mobile equipment, which is the hardware of the phone. It comprises of the various radios, be that the cellular radio, Wi-Fi, Bluetooth, or even NFC. But it may also include the various processors, screen, battery, cameras that we now take for granted in our smartphones. The second element then of the mobile station is the SIM card, or the subscriber identity module, and it's this which makes the phone yours. Here we can see that it contains various information elements, security parameters, various subscriber identities, and also potentially personal information such as address books. In the future, it may also include credit card information or possibly e-tickets. Now from the mobile phone, we will move into the network and onto the GERAN, the GSM Edge Radio Access Network. And we connect our phone to the GERAN via the interface or the air interface. From the base stations or the base transceiver stations, we connect to the base station controller, another key element of our GERAN, via the ABIS interface. Now it's important to stress these interfaces, for it is these and the messages that pass across them which are defined by the 3GPP, the third generation partnership project. So let's take a look then at the two key elements which comprise of the GERAN. Here we have the BTS, or the base transceiver station. And the base transceiver stations, or base stations and are more commonly known, provide us with our coverage across the network. We see these distributed around the countryside, by the sides of roads, on the tops of buildings, etc. It's not uncommon now to find these base stations hidden in other pieces of architecture, possibly disguised as trees, hidden in street furniture, or nowadays embedded within transportation systems. Here we can see on an aeroplane, but also on ships, trains, coaches, etc., etc. The second element then of our GERAN is the base station controller. And as the name would suggest, the base station controller controls base stations. But it will also control the mobile as well, in terms of things like power control, telling the mobile to increase or decrease its power as it moves further away from the base stations. The base station controller will also deal with handovers as well, making the decision to move the phone from one cell to another. Now, as we leave our GERAN, we can connect up to the core network, and to begin with, we're going to deal with the circuit switch core. Here we can see it connects back to the GERAN via one of these defined interfaces. This time, we refer to it as the A interface. Now, the circuit switch core is made up of two key elements, the MSC, or Mobile Switching Center, and the Gateway MSC, or Gateway Mobile Switching Center. However, it's not uncommon to see both of these functions combined within the same piece of physical architecture. Now, the MSC is responsible for setting up and clearing down telephone calls, sending text messages, etc. But it will also deal with mobility management, tracking the mobile as it moves around the network. The Gateway MSC provides our form of ingress and egress out of the network. It enables us to call other mobiles or telephones on either mobile or fixed networks. Now, sitting at the top of the screen, we can see we have a database termed the Home Location Register. Now, the Home Location Register is one master database which contains all the information about the subscribers who belong to this network. It connects to the MSC here via the C interface, which carries signaling information between the two nodes. Now, in reality, a network will not be comprised of a single MSC. Realistically, there will be a number of MSCs distributed across the network, each one providing historically a region of geographical management. Inside each of these MSCs there will be a database, and this database is termed the VLR, or the Visitor Location Register. So as a mobile connects up to an MSC, as it attaches to this MSC, then we will download subscription information about the subscriber from the home location register down to the particular MSC VLR that the mobile is operating under. And in this way we can carry out local management. The second element then of our core network is the packet switch core network, and it connects once again via various interfaces. The GB interface, which links our packet switch core network to the GERAN, a GN interface which links the various GPRS support nodes together, and possibly a GS interface which links our packet switch core to the circuit switch core. Although it must be said that in most networks around the world today, the GS interface is seldom found. So, looking at the two key network elements in a little bit more detail. Well, we have the SGSN, or the Serving GPRS Support Node. And this is responsible for the setting up and management of our data connection, the always-on connection we take for granted with GPRS. It too deals with mobility management. It will track the mobile as it moves around the network, but this time tracking the mobile for packet switch services, whereas my MSC VLR tracked the mobile for circuit switch services. The final element is the GGSN, the Gateway GPRS Support Node, and this enables us to connect out to external data networks, typically the internet, but also corporate intranets. Once again, the packet switch core network will also interconnect to the home location register, this master database which contains subscription information about all subscribers. Again, this is connected via an interface termed the GR. Now, just as a network will have multiple MSCs to support circuit switching operation, it will have multiple SGSNs to support packet switched operation. And each of these SGSNs will connect to the HLI via the GR interface. So as a mobile connects to an SGSN, we will then download packet switch subscription information from the home location register down towards the SGSN, enabling it to manage this particular mobile. So just as the SGSN will manage the packet switch services delivered to the subscriber, the MSC VLR will have managed the circuit switch services, again to the same mobile. So there we have it, the GSM and GPRS network architecture. So in this session we looked at the key elements: the mobile phone, which was made up of the mobile equipment and the SIM card. We also had a look at the GERAN, which was comprised of the base transceiver stations and the base station controllers. We then had the circuit switch core network, made up of MSCs and gateway MSCs, and also the ability to interact with the home location register. And finally, we had the packet switch core network, made up of serving GPRS support nodes and gateway GPRS support nodes, again interconnecting with the home location register.